Hello, this is Keenan Park, and this is Wylock 7th grade worksheet lesson 22. For our first problem, we have a large map where 1 centimeter on the map represents a distance of 5 kilometers in real life. And so the distance between two cities on the map is 23 centimeters, and we want to find the actual distance in real life between the two cities. So basically, this 1 centimeter to 5 kilometers is a conversion factor, and so we start with 23 centimeters and we multiply by that conversion factor. It's like multiplying by 1 because we know that 1 centimeter corresponds to 5 kilometers. And since we want the centimeters to cancel, we'll put the centimeters on the bottom here so that the centimeters gets divided by centimeters. And then we'll put the 5 kilometers on top. Centimeters cancel. We end up with 5 times 23, which is 115 kilometers. That's D. For our next problem, we have the swimming pool drawing. We want to find the area of the swimming pool in real life if every centimeter is equal to 2.5 meters. So in this case, we're going to do a similar thing as last time. You know that the area is 20 centimeters by 10 centimeters if there was no scale factor, but there is a scale factor. So at 20 centimeters times the scale factor, which is 2.5 meters per 1 centimeter, and that's the width, and then times the length or the height or whatever you want to call it, 10 centimeters times the same scale factor, 2.5 meters over 1 centimeter. And when you multiply these together, you'll get this is 50 meters times 25 meters. And then when you multiply these two numbers together, you should get 1,250 meters squared. Alright, next problem. Logan makes a scale drawing of his dog, and in Logan's drawing, the dog is 10 inches tall. If the scale factor is 5 to 12, how tall is Logan's dog? Well, if the scale factor is 5 to 12, that means we have 10 inches in the drawing, and if 5 inches in the drawing is 12 inches in real life. So for every 5 inches in the drawing, per 5 inches, which is why we're dividing, per 5 inches, we have 12 inches in real life. And so that's our conversion factor. 10 inches divided by 5 inches is 2, times 12 inches is 24 inches. And hopefully you know that there are 12 inches in a foot, so 24 inches becomes 2 feet. Alright, we have the height of a picture frame, which is 2 feet, and the length of 5 feet. If the dimensions are doubled, what is the ratio of areas of new to old picture frames? So actually, for this problem, it's pretty cool. We actually don't need the height and length. We don't need the exact numbers because we're only trying to find the ratio between old and new. So if we just say that the height is h and the length is l, we get the old area is hl, but the new area is twice the height, so 2h times 2l, and 2h times 2l is 4hl. So the new one is 4 times as large as the old one. And so the ratio of areas from new to old is 4 to 1. You can imagine there's a 1 here. So it's 4 to 1. That's B. Okay, 1 inch on the Texas state map is 25 miles in real life. 14-inch distance between these two cities. So 14 inches is our original distance. And we want to multiply by a conversion factor. We put the 1 inch on the bottom, the 25 miles at the top. We multiply. 14 inches per inch is 14. 14 times 25. We'll see that that comes out to 350. And don't forget the miles. And I'm a little confused by these answers. They seem to be ratios, even though it's asking for a distance. Let me check very quickly. It looks like the answer is looking for C, which is 80, or 1 to 80. And I find that to be rather nonsensical. So We'll just go with the answer we found, 350 miles. Unfortunately, it seems like this question was made incorrectly. Alright, next one, we have a picture of an orchard. Orchard? I don't know. Alright, what is the area of the orchard in real life? 1 centimeter is 3 meters in real life. So like before, we'll just multiply each length by the conversion factor, and then we'll multiply those together to find our area. 18 centimeters times 3 meters per centimeter. Multiply by 12 centimeters times 3 meters per centimeter. Forgive my messy handwriting. 18 centimeters cancel times 3 meters. That is 54 meters. 12 centimeters. Centimeters cancel. 3 meters. 12 times 3 is 36 meters. When you multiply 54 by 36, what do we get? That's actually a rather tricky multiplication. I'll have to write that one out actually. 54 times 36. Let's try to do that. 4, there's a 2, 2, 3, 0, 2, 1, 6, 1, 1944. It seems like our answer is 1,944 meters squared. But we'll notice that that is none of our answer choices. How interesting. I believe that this question was also made incorrectly. When we look at these answer choices, they seem a lot smaller than our 1000. So I have the sneaking suspicion that this conversion factor is wrong. Since these all are multiples of 3, perhaps they meant to say 3 centimeters is equal to 1 meter. They switched up the numbers, the 3 and the 1. Let's try it again with this new conversion factor, acknowledging the mistake they may have made. So we have 18 centimeters times 1 meter per 3 centimeters. Multiply by 12 centimeters times 1 meter per 3 centimeters. We'll multiply, we get 6 meters times 4 meters. We end up with 24 meters squared, which is again none of these answers. So it seems like this problem was maybe just screwed up heavily, or this was meant to be a 2. Alas, we know how to solve the problem actually, regardless of whatever the units are or the conversion factor is. You guys are well prepared for any real problem so long as it has no mistakes. And now, as usual, we'll be completing these equations, solving for the variable, the x in this case. Add 9 to both sides. Like always, we're isolating the variable. 7x equals, what's 37 plus 9? That equals 46. 7x, we divide both sides by 7, we get 46 over 7. X equals 46 over 7. If you want that to be a mixed number, that's 6 and 4/7. 6 and 4/7. It says the answer is 4. That's incorrect. If this was plus 9, and we subtract the 9 from both sides, then it would become 7x is equal to 28, and then it would be equal to 4. That's incorrect. So the answer is incorrect here, once again. But let's worry not. Our next one, we have 9x plus 15 minus 15 on both sides to isolate. We get 9x is equal to 45. Divide both sides by 9, x equals 5. Nice and simple. Hopefully you can become as fast as me one day. For these simple equations, the steps are pretty clear. It's just a matter of doing the arithmetic. 22.5, we add 22.5 to both sides to get rid of this negative. 10x is equal to 50. Divide by 10 on both sides, x equals 5. Here the x is negative, so we'd like to make it not negative anymore. We'll do that at the end actually for this one. Get negative x is equal to 10. Multiply both sides by negative 1, x equals negative 10. That's a negative sign, that's an equal sign. Alright, let's move on. 100x plus 1600 equals 400. If you want, you can make this step. It's unnecessary, but it might make things easier for you. If you divide everything by 100, that might be easier. you get x equals 16 plus 4, x plus 16, my bad, equals 4. And so it's the exact same problem, it's just the numbers are a little smaller, which might make things easier to work with. You end up with x equals negative 12. If you did it without that, you would have to divide in the end anyways, so it's easier this way probably. Alright, we subtract 25, subtract 25. 5x equals negative 15, x equals negative 3. Alright, we subtract 10 from both sides, subtract 10, 19x equals 38. X equals 2. And the x equals 6 from this last one once you divide both sides by 20. That is all for today's lesson. Thank you for listening. I hope to see you guys next week. Goodbye.